So yesterday we started talking about just the basics of probability, that the more we did a simulation, the more likely we were to get something that was close to the actual probability and all that kind of stuff. We call that the law of large numbers. We talked about how when we do different samples of things, we won't always get the same results, all right, because we all got different things when we did the simulation. So today we're just going to take it a little step further, all right, in terms of our discussion about probability. So let's say that we had two fair six-sided dice. So you've got some dice there on your table. Would you be more likely to get a sum of 5 or a sum of 12? So let's just think about that for a second. All right, if we've got two number cubes and we want to add up, okay, to get 12 or to get 5, okay? So let's just talk for a second. What numbers on my dice could add up to 5? 2 and 3, so that would work. Could I also do 3 and 2 since they're two different dice? Yeah, we could do that. All right, anything else? 1 and 4, and then 4 and 1. So that's what would add up to 5. What would add up to 12? 6 and 6, okay? So that's the only thing, right? So which sum are we more likely to get? 5 or 12? Yeah, we're much more likely to get 5, right? We've got 4 chances to get 5 and only 1 chance to get 12. So yeah, much more likely that we would get a 5 if we were rolling the two number cubes together, okay? So we're going to talk today about some special parts of probability. Again, they're not difficult, but we're going to do it looking at a game. Okay, so we're going to talk about model a chance process with equally likely outcomes and use that to find the probability of an event. We're going to talk about what's called the complement rule in probability, and that sounds really hard, but it's super easy. And then the addition rule for something that are known as mutually exclusive. So we're going to learn some new vocabulary today. We're going to add and subtract, and that's about it, okay? So, and then use our calculator to help us do that. So we're going to play a little game, all right? And we're not going to win bananas, but I am going to have a prize for the winner in each group, okay? But if we were fighting for the last banana on a desert island, I'm not sure I'd fight for a banana. I might fight you for a pineapple, though, all right, because I really like a pineapple. And we're playing dice. All we have is a banana and a pair of dice. Why we have that, I'm not really sure, but that's what's going on, okay? So that's our situation. And here are the rules of the game, okay? Each player is going to roll a dice, all right? So everybody's going to roll a dice. And it doesn't matter whose dice this happens on. If the largest value that we see on the two dice is a 1, a 2, a 3, or a 4, then player 1 is going to win, okay? If the largest value shown on either dice is a 5 or a 6, then player 2 wins that round, okay? So just looking at those, who do you think has an advantage in this game? Player 1, player 2, or neither of them? Player 1. Why do you think player 1, Hannah? All right, so they've got more numbers that they could win with, right? They've got 4 numbers, whereas player 2 only has 2 numbers, okay? So that's what we think, all right? Just looking at it. We're going to see if that's true here in just a second. All right, so they've got more numbers to win with, all right? Okay. Right. So here's what we're going to do. We're going to actually play this game. All right. We're going to play it 20 times with one other person. All right. So you should have enough dice on your table for everybody to have one. Okay. So if you'll grab one, doesn't matter what color, you'll just grab one. Okay. And let me just kind of give you an example. Okay. So y'all got extra over here. Okay. Which one do you want? All right, so let's say Chanel and I are playing, okay? So here's up. All right, and we're going to blow on it for luck, all right? And we're going to toss them 1, 2, 3 times, okay? So looking at our dice, there's a 5 and a 3, okay? If she's player 1 and I'm player 2, who won? Okay, so the numbers that we have showing are a 5 and a 3, okay? The biggest number of those two is a what? 5. So if I'm player 2, I won that round. Okay? All right, we pick our dice back up. We do it again. Okay? Doesn't matter whose dice it shows up on. I have a 5 and a 1. Who wins this time?
Me.
Player 1 or player 2? Player 2. Okay? And so what I would do is I would put 2 marks in the player 2 column, and we would toss the dice 20 times. Okay? And just keep up with how many times we win. So here's what you're going to have to do with your partner. Figure out who wants to be player 1 and who wants to be player 2. Okay? So that's the first decision you have to make. All right? Who's going to be player 1 and who's going to be player 2. All right? And then you're going to toss your dice and write down who wins. You'll both have the same chart. All right? Are there questions about how we know who wins? Does it matter which dice it shows up on? No. Okay? If 5 is the biggest number, then player 2 wins. If 2 is the biggest number, player 1 wins. If 4 is the biggest number, player 1 wins. All right? Does that make sense? Okay. All right. So let's see this. All right. Let's see. Got an extra. Hang on. All right. So Chanel, why don't you and Danny play? Since she's sitting right there. Okay. All right. Y'all got an extra. So John, why don't you and Esmeralda play? She's right there, so y'all can play. Joe, what about you and Jamari? Okay, and then Hannah, you can. So y'all are right there. Okay, so y'all just roll. Has everybody got a partner? Do I need to play anybody? I'm feeling lucky. Okay. All right, go. All right, so you roll your dice. Okay, you're both gonna, all right, roll your dice. All right, y'all gonna both toss it at the same time. All right, ready? 1, 2, 3. Okay, what are you saying? Okay, 2 is the highest number. Player 1 wins. Doesn't matter. That's what we know. So player 1 wins. Okay, so just put a 1. Like how many like the line okay, so now do it again. 1, 2, 3, go. All right. 2 is the highest number, so player 1 wins again. Okay, player 1 wins for a 1, 2, 3, or 4. Player 2 wins for a 5 or 6. If you tie, okay, so you both have the same number, it goes to the player who would get that number, which would be player 1. Because 2 was for no one. You only win for 5 and 6. Yeah, you only win for 5 and 6. She wins for 1, 2, 3, or 4. What does this mean? If they match, okay, whoever's number, so 5, yeah. I'll take a second to do the tallies first. Okay. If I need help. Okay. That's okay. So player 2 would get it because 6 is player 2's number. So player 2 gets the point. Okay? I gotta work. Oh, I got it. Yes. Keep up with how many times you've done it, because you want to do it 20 times.
got one more roll.
Okay.
This is our last roll.
So like, you only roll 5 times?
No.
Okay. You have to write every win. So you're on the right now. And you're on the right now with you. Okay, in the end,
Oh, yeah,
you'll have to.
they should have 10, they should have 14, and then
So you've done it 3 times, he's won 4 times, 12 and 7.
Right, listo.
Okay, so you gotta do it. You 13 more times. Okay? I'm coming.
oh yeah, I think that's for everybody.
Yeah, you finished each one? Yes. Okay. All right, and when you finish, I'll take your dice. So I can count. They're cute. I ordered them from Amazon, $50 on these.
No, you are.
Yo estoy en todo. Si sale 5 6.
These two are nice over there.
Sort of.
They were.
He was thinking about it. No, but it does make me itch. You can get back.
You guys know, that was
I got 20 more. That's small, right off your face. That's 18. Just do it 2 more times. And then make sure it adds up.
Yeah.
Okay? Alright, so be sure that your tallies for each one add up to, once you add them up, they add up to 20. I made mine count. You're welcome. Alright. Anybody else? Y'all got 20? Up. How many you got? 13. Y'all play way too many. Alright, hang on. Alright. So, this is where I played last year, okay? And so what I want you to do is count your tally marks for me, and let's just put a number. So when I played last year, player 1 won 5, 6, 7, 8 times. So 10, 11, 12, and player 2 won 12. So let's put those numbers on there, okay? So whatever your player 1 and player 2, all right, was. Okay? So since y'all did so many extra, okay? We're going to eliminate some. Hold on. Yes. What? Oh, I thought you were talking to me. Oh, sorry.
Tiene 7, ¿no?
You got 13, so you
Tienes que
keep
tener
7.
7.
Okay, so you put 7 here and 13 here. Okay. Yeah, I just you can put the number if you want to, 7 and then 13. Okay, so just put 7 and then 13. Okay, put 7 on this one. Okay, erase it right there.
6 y 7.
Now you're good. So you got 20. All right, so here's what we're going to do. All right. So the next thing it says, all right, is to find the proportion of wins. So when I did it, okay, my player 1 did not win more. That's what we anticipated, right? My player 2 won more. So we did it 20 total times. So my proportion would be 8 out of 20 and then 12 out of 20. Okay, so take whatever number you have in each column and divide it by 20, and let's get the decimal. Okay, let's get the decimal. Okay, this is why you need your calculator so you can divide. Okay, so whatever number you have, all right, so if you had 7 and 13, 7 divided by 20, and then 13 divided by 20, and just write down your decimal. Okay, that's what it means by proportion. Okay, now here's the tricky part. Okay, in your buckets, okay, there are markers. Grab a marker, okay, and then one person from each pair. I want you to come and put your number. Don't draw the tally marks, just put the number. So for mine, I would put 8 for player 1, 12 for player 2. So just come and do that. We're going to collect the data for the whole class. So one person from each pair, grab a marker, come up here, and put your number in for us, okay? So that way we'll have one from each pair. And then I'm going to have to do math, which is scary. Okay, so not everybody, just one person from each group.
You said what? I know you were.
Danny, I think you're good. Yeah, Chanel did yours. You're good. Yep. All right, so let's see if we can get some class data. I got to make it here close because I can't see that far. Okay, Lord help us. All right, can I borrow your calculator? Oh, thanks. All right, so player 1, we got 8 plus 9 plus 9 plus 8 plus 7 plus 6, plus 14 plus 5 plus 12 plus 7 plus 14 plus 9, and that gives us 108. So player 1 was 108. Okay, that's going to be important. All right, player 2, 12 plus 11 plus 11 plus 12 plus 13 plus 14 plus 6 plus 15 plus 8 plus 13 plus 6 plus 11 gives me 132. Okay. Now, in order for us to do the class total, how would I get the total number of times we did it as a class? You don't know? Well, what did I do when it was just us individually? 8 plus 12 gave me 20. Those would all be 20, right? So could I just add those two up? Would that give me my total? Yeah, let's see that. So 108 plus 132. Oh gosh, 10, carry my 1, 4, 240. Okay, so here's what we want to do. Right, thank you. Let's talk about our class proportion, okay? So for player 1, right, we're going to take 108. Okay, you don't want to work right now. That's okay. Nobody cares. All right, 108. And we're going to divide it by 240. It'll show up in a second. Give it a minute. It's tired. And then for the second one, 132, and divide it by 240. Come on. Seriously. This is so freaking frustrating. Okay. Oh, we got friends. Hey, Victor, what's up? Two people don't love me. They just like to leave. All right. It's for you. It's for you. It's from Miss McCormick. All right, let's try this again. Okay. Right. Come on. There we go. All right, we'll see. All right, so use your calculator for me. What'd you get?
I got 0.47, 0.55.
0.45 and 0.55. Okay, yep, that's what I got too. Okay, now what we just did by doing that class proportion, that's that law of large numbers we talked about yesterday. If we just did the two people, right, playing one at a time, that's only 20. But if we did everybody, then that gives me 240 samples. And so that's much better. Okay, so that's our law of large numbers that we talked about yesterday. So that just kind of came back. Okay. So what we want to do, that's what we call our experimental probability. We physically rolled the dice and this is what happened. Okay. But I want to talk about what's known as the theoretical probability. What should happen in a perfect world. Okay. So what we're going to do is we're going to actually list out all the things that could happen when we roll the two dice, all right? So that's what this chart is. So the top line would be the first dice, so dice 1, and the side would be dice 2. And we're just going to kind of put our pairs together, right? So if both of them were a 1, we'd have a 1 and a 1, okay? The next time we'd have a 1 and a 2 if I was going across. All right, a 1 and a 3. So go in and let's finish this chart really quickly. A 1 and a 5, and so on. Okay. The next row, 2 and a 1, 2 and a 2. Okay. So I did this on purpose. This chart is a way for us to figure out our what's called sample space. Okay? A sample space are all the possible outcomes. Okay? So sample space is just the possible outcomes. Okay? So that's my sample. Yes, sir. Do you have that number so you can go give it to her? Yeah, go ahead. It's fine. Yeah, just take my pass with you when you go, okay? Well, you got your note. You're fine. Okay? So sample space is just the possible outcomes, okay? So if I look in this chart, how many boxes did I fill in total? 36. 6 times 6. So my possible outcomes is 36. So when we do a probability, okay, the denominator is going to always be 36. That's how many things could have happened, okay? So let's look at the first one it asked me to do, okay? It wants me to find the probability that player 2 is going to win with the largest value of 5. Okay, so that player 2 is going to win with the largest value of 5. So let's go through our chart, and I'm going to highlight the spaces where the largest value is 5. Okay, where the largest value is 5. So that would be here. Okay. And here, right? The largest value I see is 5. Everything else, 6 is bigger. Okay, so we're good. How many things did I highlight right there? How many boxes? 1, 2, 3, 4, 5, 6, 7, 8. I highlighted 9 out of a total 36 boxes. Okay, so I did 9 out of 36 boxes. What decimal do we get when we do that one? 0.25. Okay, we get a 0.25. So that's my probability. So we just can look in the chart. So it's nice sometimes to have that sample space written out so that we could see what would win, all right, or what would work. Okay, let's do this again. This time I want the probability that I'm going to win with a largest value of 6. Okay, with a largest value of 6. So let's look at these. Where is the 6, the largest value? Okay. Is there anywhere else that 6 is the largest in that chart? No? All right, so let's count them. Okay, how many times is 6 the largest? What'd you get? 11. Okay, out of 36. Okay, and what decimal does that give me? Isn't it 305, something like that? Okay. Yeah, all right, so 0.305. All right, hold on, it's coming. Maybe. All right, so now these two things are what are events that we refer to as, come on. This makes me so mad. I think it's, I don't know what it is. Okay. All right, there we go. All right. These are what we refer to as two things that are mutually, so that's a big word, exclusive. Okay? And basically what that means, okay, basically what mutually exclusive means is that they have no common outcomes. Right? In order for the 5 to win, 5 had to be the largest number. 6 could not be a part. Okay? In order for the 6 to win, 6 had to be the largest number. All right? So there are two things that are independent of each other. They have no common outcomes. All right? That's referred to as mutually exclusive events. And so if I want to know the probability that player 2 is going to win overall, all right, that means they either need to have the 5 or the 6. So the probability I'm finding is 5 or 6. Well, the good news is I've already done both of those probabilities. Okay? So all we have to do is add them together. 0.25 plus 0.305. All right? And that gives me 0.555. Okay? It's called probability of 5 or 6. What we just did is referred to as the addition rule. All right? It works when I have mutually exclusive events, things that don't share outcomes. We can just add them together, okay, if we want the probability of either one. All right? We just add it together. Now, what's the probability that player 1 would win? Okay, well, that's pretty easy. It's everything that I've not shaded in the table, all right? Because player 2 wins if all the shaded pieces are true, right? Player 1's going to win if the unshaded pieces, well, how many is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, it's 16 out of 36. And if we do that division, what do we get? 444. Okay? Now, it's not a coincidence that we got 0.444, right? Because the last rule that we want to talk about in probability, okay? We said that our total possible outcomes was 36. We knew that player 2 won if 20 of those were covered, all right? How many are left out of the 20 to be possible for player 1? I mean, out of the 36 if I've already used 20. 16, okay? That's what we refer to as a complement rule, okay? Complement rule says this, okay? What numbers did we say probability fell between yesterday? Yeah, 0 and 1, right? So if I know the probability, okay, of player 2's going to win, player 1 would be 1 minus the probability that player 2 wins. Okay? So 1 minus that 0.55, guess what? It's 0.44. Right? This is referred to as the complement rule. It's just 1 minus what we already know. Okay, 1 minus what we already know. Because all probabilities should add to 1. Okay, now it feels like this is pretty complicated when we first look at it, but I want to show you some examples where it's really not. Okay, we're either going to add or subtract. All right, but what I do need to do is to show you some notation for probability. All right, to go with all of these words because they like to give us lots of weird notations. Okay. So flip that over to the back side and let's fill in our quick notes and then we'll do a few examples and we're going to be good. Okay? And ready to practice. All right, here we go. So learning target 1, a probability model just shows us the sample space. All right? That was that chart we filled out. But even if it doesn't show me the sample space, let's say it just shows me all the different probabilities, we have to remember that the probabilities fall between 0 and 1. Okay? So if I know all probabilities for something, it should add up to 1. Okay? So if I know all the different probabilities, they should add up to 1. Okay? So that's an important thing. Right? Probabilities must add up to 1. Okay, and we're going to use that to help us do some stuff. Okay, so So it must add up to 1. Right? So a complement in the complement rule, okay? If I have an event that we call A, its complement is A with a superscript of C, okay? That's what that is when you see that, okay? I like to refer to that when I see it as not A. Okay, so when I see A with a C or the complement of A, that means I don't want A, I want whatever else is available. Okay, so the probability of not A, all right? We can always find that complement probability by taking 1 minus the probability that we know. Okay, so 1 minus the probability that we know. Okay, and then the last thing that we talked about was the addition rule, right? I want the probability of A or B. It's just each probability added together as long as they share no outcomes. Okay, they are mutually exclusive. Right, that's what mutually exclusive means. They share no outcomes. So in one of your questions, it might say on one of your drop downs, why can I add these together? They're mutually exclusive. Why could I not add them together? They're not mutually exclusive. Okay, so that's what that means. You're going to see that word. That just means they share no outcomes. We're going to do some things next week where they do share outcomes. Right? But right now they don't. So anytime you see like an event with a C next to it, that means not that. I want the other thing. Okay? And we can always find a probability we don't know by subtracting what we do know from 1. Okay? So it helps us to find some probabilities. Okay. All right, I want to work through a couple of things with you guys just to show it to you. Right, to show you some examples and let's kind of talk through what are they asking in the question, okay? So let's look at this situation. We're talking about American adults and they give me 2 events, okay? Event A, the person has high cholesterol. Event B, they have borderline high, okay? So I have high cholesterol, I have borderline high. What are my other options? None, right? I have normal cholesterol. I'm either high, borderline high, or I'm all right, okay? Now, they didn't tell me anything about being okay, right? They only told me about being high and being borderline, okay? So it's important that we see what it is they've defined each event to be. So A is high cholesterol, B is borderline high, okay? Then it goes on and it shows me those 2 probabilities. It tells me that the probability that I have high cholesterol is 0.16 and the probability that I have borderline high cholesterol is 0.29. Right? And it's asking me to explain why those 2 things are mutually exclusive. Why do they not have any of the same people in their groups? All right? Can I have high cholesterol and borderline high cholesterol at the same time? No, and that's why. They're mutually exclusive, okay? It's because we can't have high and borderline high cholesterol at the same time. right? So one of your questions may say, are these events mutually exclusive, yes or no, and why? Right. All right, so they are indeed mutually exclusive. So number 2 says, say in plain language what the event A or B is, okay? Well, A or B just means I'm looking at the people who have high or borderline high cholesterol. That's what I'm looking at. That's who they are. Okay, so we're talking about the people that have high or borderline high cholesterol. Okay. Then it asks me to find that probability. Okay, the probability of A or B. Well, because they're mutually exclusive, we just need to add those two probabilities. The good news is they gave them to me. So all I have to do is add those two numbers together. So I'm going to add 0.16 plus 0.29, and it's going to give me the answer that I'm looking for. I believe that's 0.45 if you add it together. Okay, then question 3 says, hey, here's a new event. C is the person that has normal cholesterol. Now, they didn't tell me anything about normal people, okay? They told me about high people and borderline high people. But if I put all 3 groups together, what should it add up to? 1, okay? So to get the probability that I'm looking for, I'm going to take 1 minus the probability I already know, which is what I did in the one above it, okay? So 1 minus those 2 added together. And that'll give me the probability I don't know. Okay. Which would be 0.55, I believe. All right. Question about those. Okay. I want to look at 1 or 2 more and then we're going to be done, okay? Just so that you kind of get a feel for how these work, all right? We're going to go all the way to that 3rd extra example that I gave you because it kind of covers all of it in one thing, okay? So we're going to go to that 3rd extra example that I gave you. Have y'all bought your Halloween candy? Me neither. I can't buy it early because I eat it. Well, Rebecca usually sits outside and passes out candy, but we're worried about our new Chihuahua and what he's going to do and how he's going to act. So we're a little bit nervous. We're not sure what we'll do. So he tried to take on a full-size poodle at the vet yesterday. God love him. He's got short man's disease. All right, here we go. So let's go over here all the way to this 3rd one, okay? So it says, is it easy to pass an AP exam? All right. So colleges consider passing to be a 3, 4, or a 5. Okay. So it has given me all the scores possible, a 1, a 2, a 3, a 4, and a 5. So 3, 4, and 5 would be passing. All right. So that would be passing. So we want to find the probability that the chosen student scored less than a 3. One of the things we have to know is, are these scores mutually exclusive? Which means, can I score a 1 and a 5 at the same time? No. Okay, so they are indeed mutually exclusive. So for part A, if I want the probability they scored less than a 3, which probabilities are we looking at? 1 or 2. Okay, so that's what I'm doing, the probability of 1 or 2. They gave me those probabilities. I would add them up. Okay. And I believe that's 0.48 or 408. 408. Okay. So that's what it was asking me, right? Now, for question B, it says, find the probability that they earned a passing score. Well, that's the other three, okay? So that would be probability of 3 or 4 or 5, okay? Because that was considered passing. So we could add those three scores together, 0.267 plus 0.18 plus 0.145, okay? And that would give me 0.592. All right, and that's probably how I would do that problem. All right, I know to pass, I got to make a 3, 4, or 5, so I'd add up what I needed to pass. Now, I want to show you, I could have done this one with the complement rule after that first question. All right, because 1 and 2 doesn't pass, I could have done 1 minus 0.408, so that first answer, and still gotten 0.592. So either one of those processes is the same. Okay, so that's how a complement rule works, all right? Just means that you could subtract what you do know from 1, okay? All right, so I believe your assignment is open. Is it 4 questions, 5 questions, those of you that are in it? 4, all right, so just 4 questions today, okay? You will want your calculator because you'll have to add and subtract some things, okay? Yeah, I knew it wasn't super long. Tomorrow, what we're going to do, let me talk you through the rest of the week, okay? Tomorrow, we're going to just do some practice over 5, 1, and 2. It'll be on Achieve. We'll do that here in class, okay? So that's what we'll do tomorrow. So nothing new tomorrow. Thursday is going to be butt-ton crazy, right? It's a wind day. We got a pep rally. I won't even know what time anything happens, just to be real honest with you, because of all of that, okay? So for that reason, okay, we'll just see what happens when we get in here on Thursday, because I have no idea how much time we'll have in class. Okay, so I'm not going to panic. Just come back after the pep rally. Karen.
What?
I'm speaking on you. I said just come back after the pep rally on Thursday, because I'm not really sure what kind of time. I just had to stab you one more time. Right? I'll take that knife out of your back now.
I'm not worried about it.
It's okay. I'm just picking on you because I love you.
Before that, we have a pepperoni?
Yeah. All right. So we have a pep rally. So we'll see what happens when we get back, because I just don't know. Right? On Friday, we're going to do kind of a Halloween stat activity. It's going to be low key. All right. But just come hang out. All right. We'll do that, and then we'll go on about our weekend, because we're going to all be tired after being at the game on Thursday night anyway. All right. So it'll be low key, nothing new on Friday. Okay? Cool beans. That's the rest of this week. And then we will finish up the first half of Unit 5 next week and take our test at the end of the week. Okay? So.